Thank you, Clara, and welcome to today's virtual talk. This is the official start of the countdown to PowerTech Technofarm and our PowerTech Congress in 2 months from September 23 to 25. And we will finally meet again in person in Nuremberg. We are really looking forward to it, and we hope you are too. We cordially invite you to be part of this unique industry get-together. Take the opportunity to exchange ideas with the community on site, gather new inspiration, and get to know exciting innovations. And so that you can be there, we are providing you with a voucher code. And Clara will send you a link in the chat so that you can easily secure a free ticket. Today, our VDMA special talk is taking place, and the VDMA is a long-standing partner of PowerTech Technofarm and has prepared 3 exciting presentations by member companies on the topic Innovative Dust Management, Solutions for Safe and Efficient Production Processes. A big thank you to our speakers, Thomas Negerle, Head of Sales Keller Lufttechnik GmbH and Co. KG, Christopher Muschiol, Chief Revenue Officer, Heatfilter GmbH, and Johannes Götz, Director of Sales, Herding GmbH Filtertechnik. And a very special thank you to the VDMA for co-organizing this talk, and especially to you, Christine Montigny, consultant for general ventilation technology and air pollution control at VDMA. It's great to have you with us today, and I would now like to give you the floor.
Well, thank you, Marianne. Dear participants, on behalf of VDMA, Europe's largest machinery and industry association, and especially the Air Pollution Control Department, I am delighted to welcome you to the virtual talk today. We will focus on the 3 different perspectives of state-of-the-art technologies for dust containment, filtration, and process integration in high-risk industrial environments. And our first speaker will be Thomas Negerle from Keller Lufttechnik, who unveils contaminant-free handling solutions that protect both employees and products from hazardous dusts, featuring real-world applications and high-safety innovations. Mr. Negerle, the floor is yours. Thank you.
Christine, thank you very much for your warm and welcoming words. I do not work often with Zoom, so give me a second to start my presentation. And no, that's not the right one. We have tried this 10 minutes before, but as it usually is. Here we go. Thanks again for the for the warm words. My name is Thomas Negerle, Head of Sales from Keller Lufttechnik. We are very proud to be part of this virtual talk to provide exciting information and free information for you, especially in my presentation for containment technologies combined with user safety and process reliability. If we think on hazards, if we think of hazards, we have several types of hazards. You can see simple, easy dust on the left-hand side, for example, sugar, flour, and so on. And even those kinds of dust can cause several disadvantages to your health for your workers, which cause illness. And if you maybe work 8 hours, 5 days a week with this in this environment, you have huge health disabilities at the end. This is one big dangers we have. And on the other hand, we have a very high risk of cross-contamination, which can also cause big issues, even in the pharmaceutical industry. If the process is not working well, if the machine is dirty all the time, you get an additional risk of explosion, so you have to consider ATEX regulations, but you have also a big risk of wear of your machines, so you have very, very high maintenance efforts, cleaning efforts, and so on. And for this reason, it's very important to have an overall look over the process, over all your systems, to get a solution for you that fits into your needs, which is cost effective, but doesn't have any leak of health insurance for your workers. If we are going to the dust, we have some classification of dust. So we call it the OIB level. It's a method to classify substances in their hazardous potential. It's going from 1 to 6. 1 is a low hazard, 6 is a very high hazard. This is not a fixed regulation, but if you work with determined companies, they have made it their own standard, let's say. Why they did this? Because it's much easier for their workers to go there and say, hey, we have a new substance here in our factory and our laboratory. It's classified as OIB 3, for example, or 4. Then to say, hey, we have a new substance here with a OIL level of 25, for example. Everyone knows what to do if he has an OIB level of 4. So this is the health issue you can have with, or the classification of dust for the health. And then we have another classification, and this is the ATEX classification of your dust. First of all, what do we need to have an explosion? I'll start from the very first beginning. For sure, we need a substance that's combustible. Then, for sure, we also need a sufficient degree of fineness. Everyone knows this. The correct mixture. Then, for sure, a source of ignition and oxidizing agents. If those 5 come together, for example, in a filtration unit, they can cause an explosion there. So we try to cross one of those points to make sure that no harm for your workers will be done. If we can't cross one of those, maybe the source of ignition, because of a very low minimum ignition energy, we have to design the filter in a way that it's still safe for everyone to work around. So if you come to us and ask us what kind of, or if you want to have a safe production from our side, you need to know some specific values of your dust. For example, as I mentioned before, the minimum ignition energy, to decide whether we need explosion protection or we do not need explosion protection. And then for sure, KST values and the pressure, maximum pressure for your dust. So how do we bring this in a very, as I mentioned before, it's an overall process. The customer needs to have a look over his whole production. And there we start with STOP. STOP means, or STOP principle means, first of all, you have to substitute the most dangerous substance. Then you can go for technical protective measures, then organizational protective measures, and at the end, on the very end, the personal protective measures come into account. Since we as a filter manufacturer are only a small part of this STOP principle in the production of our customers, we are not able to substitute the biggest hazardous dust, for example. We concentrate on the top, on the technical protective measures, so that we bring in one piece, one of the several pieces for the customer who he can rely on, that we have technical, the most up-to-date technical device with a very low organizational protective measures and least personal protective measures. So this was a quick overview over the hazards that we have in a production where a lot of dust can be exposed. Talked a lot of we, but who is we? So we are Keller. We are Keller Germany. We are a filter company founded in 1903, in Kirchheim-Teck, close to Stuttgart. We have our knowledge spread over 350 employees. Our mechanical and in-house mechanical and electrical engineering department brings the vision and the requirements of you as a customer into our product, into a working product, and our installation and commissioning guys will make sure that the system is installed in the correct way, according to the guidelines, according to the most up-to-date guidelines, and is running like it's like 50,000 systems over the world will do it right now. All over the world, as I mentioned, our head office is located in Kirchheim-Teck, but with our subsidiaries in China, US, and also Switzerland, we are always close to our customers to provide the engineering knowledge that is needed for specific markets like in China, like in US, well known for the customers that the local regulations are met, doesn't matter US, China, and so on. And an additional very important point is the service time. So if we would bring our service only from Germany, we would have very long travel times and so on. So our guys in US, in China, and Swiss have their own service department that provides very short lead times. In this case, for all of our 2,500 satisfied customers worldwide. Those customers are divided in several industries. Just a quick overview over some. We have, for example, the chip industry, in the wafer production, in the battery industry, special slurry mixing, battery assembly, battery manufacturing as an overall process. Then for sure also the food industry, where we have our filters used for truck loading, ship loading, and so on. Then for sure chemical industry for compounding plants, plastic plants, paint production, also mixing, weighing, feeding for epoxy productions. And at last but not least, pharmaceutical industry, and many, many more. Just a small overview over this. And since we have recognized that, especially in the pharma, chemical, and food industry, we have decided to bring up our new filter, the PCF1, that meets the requirements that we have there, with the airflows we need there, with the small airflows, with the high, with a filter that is able to handle the very high potential substances up to OIB5 level. We have inside 2 HEPA stages. First one is a pulse jet cleanable HEPA stage. Second one is a secondary stage for if the first one has an issue, for example. For the disposal, we have talked to several customers and we have focused on the endless liner system compared to several other possibilities that we have, or we could have installed, like a back in, back out with the O-ring system. but we decided to go for an endless liner system because of the easier handling, and the focus was there on the daily doing of the workers. For sure, the O-ring handling is fine for the HEPA stages if they have to be changed, in our case, once a year, depending for sure on the process and the dust that's coming from. But the daily handling, the maintenance guys, daily work was very in focus from us, so they shouldn't need 5 to 10 minutes to change the full bag on the bottom, but 1 minute should be the maximum time that they should use. And this, for sure, GMP orientated, with a GMP orientated filter housing made in carbon steel, made in stainless steel, depending on the needs of our customers, up to 1 bar pressure shock resistance. So also suitable for ATEX dust. Changing the filter units, easy back in, back out system. This animation doesn't show the bag at the moment, otherwise you wouldn't see anything. Filter elements out, new one in, and the same with the endless liner unit. Big benefit of the endless liner unit is you have the O-ring handling just once a month, and the daily change, as I mentioned before, is done in a very, very short time. 1 minute. You just have to toss down the endless liner, crimp it with a Lugaya system, depending on the OIB level that is required for your process and for your personal safety. But with a Lugaya system, we can go up to OIB 5. Just toss it down, crimp it, and production can go on, and this is done in less than 1 minute. And I've mentioned the modularity, or the small airflows that we have that the PCF1 is designed for. So we can bring it up with a top-mounted fan. If we do not have the height, we can place the fan beside. If one PCF1 is not enough, we can just bring several in a row to fit the customer's needs. And this is not the only thing we can do. If the PCF1 is not working or is not the right filter for your process, because maybe you do not have the ATEX requirements, we can go for several other possibilities from our portfolio. Just a quick overview for the main industries that we have right now. For the pharmaceutical industry, we have the PCF1 for sure, placed at a customer with a beside placed fan so far. Then for chemical industry, in this case plastics production, several tons of plastic are produced in this facility. We have an airflow for the PCF1 700 to 1000 cubic meter roughly, and the system here has 56,000 cubic meters per hour. So from small to big airflows, we have a very high range. Dry filtration systems, but also wet scrubbing systems. In the food industry, we have set up several filters for ship unloading, truck unloading, food processing, and so on. Battery, most of those filters are used for slurry production, where all the critical masses come together with the solvents, with the lithium, which is very dangerous during handling. And in this case, because the airflow of the PCF1 was not enough, we choose a standard dry filtration system and equipped it with an endless liner unit at the end. And also chip industry, also here we have the ATEX version with a Rembe explosion device, back flap on the inside, and a big bag on the bottom. So this was a quick overview. We have effective containment technologies, and for this, I wanted to show you what kind of dangers and hazards can show up during a process, during a production, what is important for us to know. And if we have all the information that we need, we can provide to you a GMP-conform system, which is able to get up to OIB 5 and ATEX conform. Industry 4.0 is a very, very important point so far, which has also influence on the safety and operational style of your process at the end. I didn't mention it in the presentation so far, but as I said before, the electrical design department is in-house, so we have the possibility to connect all the systems for you as a customer to your needs. You can get a message on your mobile phone if you like to, if the filter needs to be changed. And as far as you allow and as far as you want to, we can sum up all the information and make it visual for you. And with our knowledge of our several thousand systems in operation, we can guarantee a 24/7 operation with our systems, which is guided by our engineering know-how. And if you like to, we install it turnkey from the capture with the ductwork, filter, sound protection measures up to the exhaust air. So, and with this green, with this points, we can change the stop light to a green light with the color solutions that fits to your needs. With this slide, I'm on the end of my presentations. Thank you so much. See you, thank you, and see you on PowTech 2025.
Thank you very much, Mr. Nägele. Very interesting presentation. So if you have any questions now, please feel free to use the F&A button at the bottom of your screen. You find it near the chat function. There is a button which tells F&A or Q&A, and there you can type in your question and I will forward it to Mr. Nägele. So I will wait a few moments that the questions can be typed in. So yes, I see we get a first question. As the headline or in the headline was mentioned, free of contaminations. What are your newest developments here? BIBO is a method known as contamination minimized.
That's correct. To be honest, the newest target in contamination-free BIBO, yeah, is correct. Is well known. Also, the endless liner is well known. We try to combine all the available methods on the market, now fitting to the customer's needs. We have talked a lot with our customers before we have designed this filter, and they set up a specific requirement for a special OIB level, and then we try to combine all those information that we got into our new filter or in this filter, and this is the result of it.
Thank you for answering this question. So I have another question that comes in over the F&A button. Can filtration system handle dust with moisture?
It can in small amounts. As long the filter unit is located inside, and we do not aspirate air with a humidity of 80 to 90%, it can handle this, and if it's not 24/7. Otherwise, depending on the dust that we have into the filter system, it get a very, very sticky, muddy substances, and this is quite tricky, especially if you use the HEPA stage, the cleanable HEPA stage, as we do, and also our colleagues from HED do. So maybe also Mr. Mujiol can answer this question later on.
Perfect, thank you. One another question. In your opinion, how can economic requirements be combined with increasing safety standards in this area of containment in practice? And where do you currently see a realistic target range for OEB levels in your industry?
That's a very interesting question. Some parts I think I have answered before, because we, on the systems on the market, we have done a lot of research with our existing customers where we have placed our system already, and most of them say up to OIB 4 is the most common range. Also OIB 5 from time to time. But for sure, the substances get more and more critical. We, as a community, will be more, or want to have everything more secure a little bit. So let's see where it's going. At the moment, we see most processes on OIB 4 or 5, or even lower, and only very specific processes like laboratories, for example, on a higher OIB level.
Okay, perfect. Thank you. And another question is, how is the filter be exchanged under OEB 5 conditions?
There we have, so we are on the latest stage where we can do this in a dry way. We have also done some research and tested this by our own. And according to the ISPE or ISPE regulations or guidelines, let's say guidelines, we can go up to OIB 5 with a dry system, and everything above should be done in with wet conditions. So we do this with a back-in, back-out system. We have some specific design of our O-rings and closing devices, so we can achieve the OIB 5 level with a back-in, back-out system.
Thanks. And another question there is then, it is also, I think, possible with an endless liner system, or is it also with an endless liner system?
For the HEPA stages, no. The space would be too big, and based on the economic point and especially the economic point, and due to the fact that the lifetime of the filter cartridges or filter HEPA stages will be more than 1 year, so you have to do this typically once a year. Also with our customers, we confirmed that it's okay to do this with a back-in, back-out system. That's the reason why we did not do this with an endless liner.
Okay. I think we have time for another question. So in your presentation, you've mentioned the dangers of dust and hybrid explosions, and explain how the PCF1 was designed to deal with them, especially in terms of resistance to pressure shocks. How you make sure these protective measures would actually work in an extreme situation, and what test procedures or verifications did you use?
Yeah. We have done this based on the latest ATEX regulations that that are on the market. The design, I could go into deep, but I do not think we have time for this. It's based on the volume of the PCF1. And based on this, we can go for a special KST value, also for hybrid versions and also gases. And to make sure that this system also will work under extreme conditions, we have done testings, and we have the certificate or the confirmation of an external department that this system works with dust alone, with gases alone, and also with a mixture of both.
Okay, thank you. So then, if you do not have any questions left, we will go forward to our next talk. So then thank you again, Mr. Nägler, for this interesting talk and for answering the questions. If everyone has a question left, please feel free to write Thomas Nägler or to write to us, to PowerTech TechnoFarm team, so then we can also forward and get the contacts between us, you. So please feel free to do that. So thank you again, Mr. Nägler, and we now hand over. Thanks. So now we continue with Christopher Muschiol from HET Filter GmbH and his talk about efficient containment in practice, reliable dust extraction solutions for highly potent substances. You can look for a very interesting presentation, I think, and have fun. The stage is yours.
Thank you very much, Clara. And also thank you, Christine and Mariani, for giving us the chance to present everything. And also thank you, Mr. Thomas Nägler, for this good presentation. I have also some similar slides, so I'm hoping not to get too boring with some other slides, but I will do my very best. Yes, let's start with my presentation. Again, yeah, my name is Christopher Muschiol. I'm working for HET Filter for about now 15 years. And I'm working currently as the Chief Revenue Officer. And so that's something else like the Sales Director. And hopefully now our presentation can start. Just give us a second. So now you should see a big HET logo. Clara, if we cannot see anything, please say something. Otherwise, I will start with our presentation. Okay, HET Filter. We are a company which was founded in Germany in 1998. And since then, we are supplying filtration systems or dedusting equipment for the pharmaceutical and the chemical industry. We are also delivering the filter elements itself. So we have the dust collectors and the filter elements here in our facility. And we are delivering it, of course, yes, worldwide. And now we're going a little bit deeper into the part pharmaceutical industry. Of course, a little bit also chemical industry, but the main point is pharmaceutical industry. And dedusting of processes in the pharmaceutical industries, like if you want to dedust machines like tablet presses, coaters, fluid bed dryers, so all machines which are producing powders or tablets and which are generating dust. And if you are in such companies, and if you are working for such companies and you are on this presentation, I want to say thank you, because you are have decided to look about employee protection, to look about health, and also to look about to protect the environment, because yeah, dust collection or filtration of such processes is a really difficult part, but it's also necessary to keep employees healthy at the end. So, and now if we are in such a process, for example, for planning a new system, a new facility, a new production area, and you are going to look for the dust collectors, you need to look for 4 main technologies. The first technology is the HEPA filtration. HEPA filtration is to ensure the highest purity of air, because in pharmaceutical industries, the substances are mostly harmful. They could be toxic, and they are mostly in a really, really fine way in those industries. So only HEPA filters are able to filtrate finest particles in an area of less than 1 micrometer, and they have the right efficiency to filtrate all those harmful substances. And we are always looking for a two-stage HEPA filtration. So our filter systems are always working with at least minimum 2 filters, or sometimes also 3 filters, to ensure the highest purity of air. Together with the HEPA filtration, of course, the main point is containment, but what I will explain a little bit later on more about that. But containment is used in the pharmaceutical industry to protect the employees, to protect them to not come in contact with harmful substances like active ingredients or other stuff, and to protect, of course, the product, which is it's produced, because at the end, pharmaceutical industry is producing medicines, and at the end there are humans who take these medicines and who wants to get a healthier life. And together with the containment, pharmaceutical industry always looks for a GMP compliant design, because we are not able to deliver a machine, a device, and that's all. We have to ensure that the machine or the dusting equipment, anyway, any machine is delivered into the pharmaceutical production area, has to have the right functions, has to have the right performance, and that just has to be qualified and validated. Only the right machines can, at the end, look for a right medicine at the end. So together with the HEPA filtration, the containment, also the GMP requirements are really necessary. Yeah, and last but not least, also what we are also doing is explosion protection, because powders and dusts are generated in the pharmaceutical industry. They are mostly combustible. They are at the end also explosive, and that needs that we need an explosion protection by design on filter system, but also on other production machines. And that leads that is also necessary for that. And all those 4 technologies are necessary to plan the right dust collection process in the pharmaceutical and also in the chemical industry. And all those 4 technologies are combined in one head filter system. That's what we are doing mostly with our systems. All of our system has all of those 4 technologies in one device. But let's go and talk a little bit deeper into the containment part. So first of all, when we talk about the containment, we have to know what is containment, what is this buzzword. Everyone's talking about containment, but what is that exactly? And at the end, it's a measure to protect employees or people against a substance. Those people, like we are looking in these pictures, are working with substance which could be toxicity, which could be harmful or something else. At the end, the amount of dust, the amount of this substance is important, because even in smallest amounts, such substances can be a damage for the human body. And there's also a keyword. It's the 1 microgram per cubic meter. This keyword is also a requirement for many pharmaceutical companies. What device, a filtration systems, or a process is able, or what at least is able to come out. So most of our customers says, okay, when you deliver a filter system, there should be an exposition of not more than 1 microgram per cubic meter against an employee. So, but at the end, what is 1 microgram per cubic meter? It sounds not so much. It's not a high amount. And when I'm talking to our customers or to other colleagues, if you see the dust, it's the end. It's too much. So 1 microgram per cubic meter is so less that you are not able to see it, and you cannot weigh it at the end. It's so less of amount. You cannot imagine it. So I have a short example how to imagine 1 microgram per cubic meter. You can imagine a halved tablespoon that has a weight of about 20 grams. And now you pour that tablespoon into the biggest building of the world. And I'm sure I cannot ask you directly, but I don't know if everybody knows the biggest building in the world. That's the New Century Global Center in Chengdu in China. That has an incredible volume of about 20 million cubic meters. So it's 400 to 500 meters and 100 meters in the height. 20,000 cubic meters building volume. And you pour that small amount, that halved tablespoon, into that building. And that's the same relation. That's at the end the same relation or the same ratio, like 1 microgram per cubic meter. So it's really, really small, but it's a requirement we have because such substances like cytostatica or other medicines can have a damage in such small amounts on the human body. Of course, not directly. If you are pressing 1 microgram, you are not falling down and, and dying, but it goes constantly, one day by day, week by week, year by year. And at the end, after some years, you have a health problem. And that's why there are requirements on such substances which are necessary to protect human health, to ensure product safety, of course, cross-contamination, another buzzword, and to prevent environmental contamination. So yes, even the smallest exposure can be harmful. That's important with the containment, and containment are all measures to prevent or to protect those employees against that substances. How works that in practical regarding dedusting machines? So now we can imagine here something like a pharmaceutical production line. We have an isolator, a wiring isolator. We have a fluid bed dryer, tablet press, and a drum coater and everything else. And in that production line, there are medicines produced. There are active ingredients. And of course, from time to time, there could be a leakage or there could be a contamination. And to prevent that contamination, you need dedusting equipment. Of course, you put a technical area on top, put a big dust collector on it. You connect all those machines with the dust connector, and the dust collector sucks all the harmful air, all the dusty air into itself, filtrate it, and let the clean air out. So that's all, isn't it? No, not really. Because what you are doing now, if you have a process like this, you put the risky dust, the risky substance from a clean area, from a clean room, which can be cleaned really, really good, into a technical area, into a dust collector. And during operation, of course, dust collectors are really, really tight because they are working in vacuum and everything, which when there is a leakage or something else, the vacuum sucks the air in and also the dust stays in. But of course, from time to time, you have to do filter change. You have to do dust discharge. You need to maintain such dust collectors. And then what we are seeing, what most of the companies do is they put their workers into PPE, personal protective equipment, and protect them against those substances. And when they are doing the filter change, for example, on a dust collector, of course, they are protected. But the environment of the technical area is contaminated because on normal dust collectors without containment measures, there are no, the dust and the harmful substances can go out and can fly through the technical area. And everybody who knows in the pharmaceutical industries knows how long dust particles, which are have a smaller diameter of 1 micrometers, how long they can fly through areas. They need weeks to fall down. And after that, you're not able to, also before that, you're not able to clean such technical area. So when the worker is finished with his maintaining or with his filter change or everything else, the dust stays in the technical area. And after that, if it comes another person for an audit or something else, or you have to repair another device, he is directly in contact with the substances in the technical area. So, and as Mr. Nägele mentioned, we are also working with the STOP principle. We have also the same, solution concept. We try to follow substitution, technical measure, organizational measures, and personal protection always as a last resort. And what we are doing is also, in the first way, we are looking for technical measures because substitution is a little bit more difficult and not always possible. But we are working with technical measures, and after that, with the organizational measures. And how should it look in the right way? So we are going to the principle that you need the right dust collection system, the right filtration system for the right pharmaceutical process. So each process machine is equipped with a dedicated dust collector with the right technical containment measures. And we also consider that you not always have to place the filter systems into the technical area. Yes, you can also execute those systems in the clean room, of course, with the right execution, like in stainless steel and GMP compliant and everything else. Also mobile for difficult processes or for difficult processes. And then you have the right dust collection solution for every process. And then you can also choose the right containment measures for the right processes. For example, you need on a drum coater and other containment measures, like on a fluid bed dryer or something else. Also, regarding explosion protection, that's also the same way. You can look for the right explosion protection for the dedicated process. So as a conclusion for that, personal protective equipment should always be the last resort for the protection of employees and the environment. And a suitable exhaust air concept for process plants leads to safe removal of hazardous exposure. What I am talking about is also written down in a handbook. There's from the ISPE, there are really, really good handbooks regarding containment. They are available in German and also in English. And if you are more interested in containment regarding dedusting systems, there's a whole topic, everything about containment on dedusting systems, but also on containment on other process machines like tablet presses and also other procedures, also GMP compliant containment and many, many more. It's a really, really good handbook, and I can only recommend to have that on your desk. So let's get a little bit more detail into what are containment measures on filter systems. And of course, if you have to look for containment, or if you want to use filter systems in your pharmaceutical production area and you want to put it into your containment chain, you have to consider two main procedures. That's the filter change and a dust discharge change. If you change the filters, you replace the loaded filter element and put a new unloaded filter element into the filter system to ensure that we always have the right filtration efficiency. And when the dust discharge is changed, with a container which contained the collected dust has to be emptied. And there are, of course, many, many possibilities for the filter change. We are working with the safe change principle. We do it in dry containment up to an OEL to 1 microgram per cubic meter. So we change the loaded filter if we by using a plastic bag, where the loaded filter will be put it in, and we cut it off and put it away, and we put a new filter element, a new plastic bag, and bring it into the filter housing. When we are lower than 1 microgram per cubic meter. We also doing the safe change, but prior to safe change, we wet the raw gas area, the raw gas area from the filter element, and we make everything wet to prevent a dusty airborne in the filter housing. So by using a little bit water, also steam can be used. By using water, we have not so much particles flying around inside the plastic bag or something else, and we ensure a higher safety in the containment measures. That can also be done for the dust discharge, of course. And for the dust discharge, we also have, of course, endless liners, but an endless liner has also to be changed via the safe change principle at the end, because an endless liner is not endless, it's only a long tube, and it has to be changed by the safe change system. But on the dust discharge can also be equipped with, for example, containment flaps, pneumatic conveying systems, and much more, where there are much more solutions. And if we have higher requirements in the dust discharge, we can put a whole clove box, a second barrier around it, to not come in contact with those harmful substances. Yes, as a conclusion, what we are talking about is pharmaceutical dedusting systems. And when the dedusting systems are handling harmful substances or active ingredients in such production, they have to be put into the overall containment strategy. It's not good, or it's not possible to take some deduster or anything else on top of a building and say, okay, that deduster suck everything up and then we are fine. You need to consider maintenance, you need to consider filter change, and at the end to protect your employees. And as already explained, technical containment solutions are preferable to personal protective. And yes, also cleaning such technical areas are much more cost effective. And therefore, you have to consider that some filter systems could also be placed into the clean room or in something in between. We also have through-the-wall solutions where you put the filter front, where the filter change and the dust discharges, and only the front is in the clean room, and the back of the filter system could be in a technical area, depending on the facilities on the building, of course. And integrated filter systems, which have a high-end HEPA filtration, containment, explosion protection, and that all for the pharmaceutical industry are the best way to have your pharmaceutical solutions, your pharmaceutical process safety. Okay, what I have now is that system you have on the picture. We have it also here in between beside me. And I only want to shortly explain what we also have here. That is our called head compact filter system. And the head compact filter system is a system which can be used in clean rooms, in production areas, because it's completely in stainless steel. It's completely mobile. And this system we have here is able to handle up to 500 cubic meters per hour. It's perfectly suitable for small tablet presses, small process machines, or R&D solutions, or working benches and everything else. The main part of that head compact is everything what a filter system needs is in one housing. We have 1, 2, 3 HEPA filter stages. The first one is also cleanable. It's not a jet pool system, it's a more smooth system which cleans the filter in a really silent way, in a really smooth way, but also compressed air is needed. Then we have also a dust discharge in it, we have a fan in it, and also the completely control system. So that system is a completely compact system. We have a raw gas inlet, clean gas outlet. It's mobile, you can put it from room to room and can use it on your dust collection systems in the pharmaceutical industry. Okay, I think that's all what I wanted to tell you, and hopefully you understand me in a good way, and you imagined the importance for employee protection, and I'm free for any questions.
Thank you very much for this interesting talk, Mr. Mushiul. So if you have any questions, as he said, please feel free to use the F&A button at the bottom of your screen and type in your questions, and then I can forward it to Mr. Mushiul. So I give you a few moments to type in your question, and then I can tell them. So we have a question over the F&A button. So for those mentioned tailored systems, will you prepare the full concept for those needs as a part of an offer, including safety review?
Oh, sorry, I didn't get it really. Can you repeat
I
it,
can
please?
repeat it, no problem. For those mentioned tailored systems, will you prepare the full concept for those needs as a part of an offer, including safety review?
Of course, yes. A safety review is always part of our project. So yeah, that's a good point, because we mostly made tailored systems. We are working in the project management. We have, of course, our modular design for the Ed Compact and also for our other units. But the Ed, it's a project business. So we are building, we are engineering our systems dedicated to the customer needs. And a safety review is always part of it.
Okay, perfect. Thank you for answering that. Another question. What do I need to consider when planning a filter system for the pharmaceutical industry?
Yeah, first of all, as already explained, you have to look for technologies, but at the end, for a standard project for the pharmaceutical industry, they are working many departments together: engineering department, safety department, also quality department, and also the producers or the end customer itself, and all those departments working on a so-called user requirement specification. And in that specification, all requirements are listed down, and those 4 topics I have already explained should be a part of that. So to consider what to consider is a little bit difficult, but at least those 4 technologies should be considered. And at the end, also the performance requirements like volume flow, like temperature, explosion protection, and everything else.
Perfect. Thanks for explaining. So then I can look if we have another question. So first of all, we have a questions a little bit longer. So if you have the opportunity then to see the questions for yourself over the F&A, it's maybe perfect. Then you can write or see the question also. So first of all, the people thank you for the interesting presentation and for the insights. In the previous presentation given by Mr. Nägele, it was pointed out that the containment level up to OEB4 is sufficient in many applications, and that OEB5 usually already offers a very high level of protection, both economically and technically. Now you offer systems up to OEB6. In which specific areas of application do you actually see these already in everyday industrial use, for example, beyond laboratory or special applications? And in your opinion, is OEB6 more an exception, or do you see a real industry trend towards such high security requirements? And if so, what is driving the development?
Oh, that's a good question. Yes. First of all, yes, thank you for that question. OEB5 or OEB6 requirements are mostly in the industry with active ingredients. So those companies which are producing active ingredients, they are working mostly with OEB5, OEB6 systems. We have already several customers, and we make from our business a really good, in the last year, a really big project with OEB5 or OEB6. requirements, as already explained, active ingredients. Also, and that's the question with the trend, there's also, it's a little bit similar with the explosion protection years ago. When the requirement starts with a new project, the requirements are here, and we need everything. Customer says we need everything. We need a highest explosion protection. We need highest containment, and we need highest everything. And then, of course, we say yes, we can deliver it, and we start the project, and we say, okay, you need that, this, and this. You need a unit which has the technical containment measures, or you also a unit which has a technical explosion protection measures. And after they see if there is what the amount of to-do is with such projects, then the requirements can also be a little bit lower. Then it's not only OEB5 or OEB6, it's also OEB4. That's what we also faced last year, but the main high containment projects are really real high containment projects, and they are also really strict in that requirement. So it leads to that point that we have customers who said, okay, we believe you have a high containment systems, but we want to test it by ourselves. So we deliver our systems, and we have done, of course, our own exposition tests and our SMEPAC tests, or what else is the name for that. But the customer takes its own SMEPAC test, its own exposition test to ensure that there's the real containment measures executed. So I think I have answered 2 of those questions. I'm not sure, but there were 3, or the last one?
The last one on the first one was in which specific areas of application do you actually see these already in everyday industrial use? Yeah. And the second one was that, in your opinion, OEB6 more an exception, or do you see a real trend? So that's the thing I think you've answered. And if so, what is driving this development? I think you answered the question very good.
The driver is always EHS. So environment, health, and safety. Those departments on customer side are always driving such projects, and combined with the engineering departments.
Perfect. So I think you answered it, and we also get the perfect and the thanks again. So I think that was a very good answering. And we have also another question that I think it's good when you answer it too. So what explosion protection is applied to the filter in the screen that we see now here next to you?
Yes. So for dedusting equipment, you mostly have 2 main explosion protection measures. The first one is preventing any ignition surge. So to have a look at if there is an explosive atmosphere, that can be no ignition surge in it. That system is, or all of our systems are standardly ignition free. And another, or the other explosion protection measure is the constructional explosion protection. And our filter system, or this filter system, is explosion pressure shock safe. So in case of an explosion, the explosion stays inside the housing, and nothing comes out, and the filter housing stays in its execution in itself, and it's completely explosion pressure shock safe. That is for dust which has any minimum ignition energy, and for dust which has a K value of up to 590 bar per meter per second.
Okay, perfect. Thank you. We get another question. So the person said it is interesting to see 2 supposedly similar dust extraction systems and their possible applications. So Mr. Nagler mentioned in his presentation that damp or sticky dust poses particular challenges for dust extraction. How efficient are your filter systems with damp or sticky dust, especially in view of the challenges described in the presentation?
Yeah, that's also a good question. Mr. Nägele is also completely right. So sticky dust or moisture in the process is always challenging, especially for HEPA filters, because HEPA filters if you know HEPA filters, they are folded. There are some channels where the dust has to fly in, and if the dust is sticky or it's moisture, the dust sticks on the filter element and is not able to be cleaned or to pulled back from the filter media. For that, there are some solutions, of course. Not everything is possible. That's what I also have to say. Not everything is possible, but there are some solutions by, for example, coating the filter media with a PTFE coating, or put another substance into the dust collection process, and also to coat, for example, the whole filter housing in the inside with a PTFE coating. So it's difficult to say it in a global way. We always have to look in detail of the process, what machine we want to use, what is the process, what we have for a substance, for example, how big is the volume flow? Are we talking about 500 cubic meters or talking about 50,000 cubic meters? And then we can go in detail regarding sticky dust. So we have solutions, that's true, but it has to be looked in detail. Mostly part is to work with coated filter medias, filter housings, and to put another substance into the process.
Perfect. Thank you, Anna, for answering all those questions. So if any questions left or are open, so please feel free to contact us or Mr. Muschel directly. So then you can get in contact personally. So we are running a bit of time. So then I say thank you again to you, Mr. Muschel, for this interesting talk and showing also the machine next to you. And we will then forward. Perfect. Thank you. So we continue our virtual talk with Johannes Götz from Herding GmbH Filtertechnik, and his talk about dust collection solutions for pure productivity in process filtration and extraction systems. I think we can also look for a very interesting talk. So Mr. Götz, the stage is yours. Enjoy.
Yeah, thanks a lot. Thank you for the organizing team for setting up this unique event. Also, thank you to the previous speakers, Mr. Nägele and Mr. Muschel, for the very interesting insights they offered us. So now it's about for me to make the final presentation of the day. The topic is maximizing process efficiency through advanced dust collection systems. And let me start also with a short introduction about the company. Herding Filtertechnik is a company located in the southeast of Germany, in Amberg, employing around 450 persons in Germany, generating a worldwide turnover of around 100 million euros. We are on the market since 1977, when Mr. Herding started a one-man show that has developed step by step over the years. And yeah, what are we offering? Filter elements and filter units. We are one of the few companies on the market that do both. We are developing and manufacturing the filter elements and developing and manufacturing the filter units where the elements are installed in. So the perfect fit of element to unit. And of course, everything that is around, including the service in terms of installation, commissioning, maintenance, repair, but also training and consulting of customers is in our portfolio. Myself, I'm Johannes Götz. I'm the Director of Sales at Herding. I've joined the company in 2002, so I'm here for more than 23 years. And I'm happy to show you a little bit how you can maximize your efficiency in the processes by using the correct dust collection system. Means what kind of small wheels you can turn in order to get better. Okay, on the company, where are we located? It's just a small adder. We are globally networked. We have got own divisions in Europe, in the United States, in Asia. The latest one was founded in India last year. In China, we are since almost 2000, beginning of 2000 years. And next to that one, we have got a network of partners all over the world to cover the markets where our customers are. Our customers, we try to work on many feet. We are working in different applications: additive manufacturing, battery, minerals, chemical, pharmaceutical industry, laser processing. So I saw from Mr. Nagel and Mr. Musciol, there are some things the same. So this means we're working on the same physics. I'm just putting a little bit of a wider look outside of pharmaceutical industry and the high hazardous dusts in terms of high potent pharmaceutical ingredients or other very toxic measures. But there are also other hazards coming from. So I will touch similar things than the previous speakers. Yeah, when I talk about filter units, I think the reason why we use filter units is clear. First of all, and this is the basis of all, we have to remove particles from gases. This means protecting man, protecting environment, protecting machine. This has to be done within all the norms that are applicable, be it the European Directive of Machinery, be it ARTEX, be it ASME, NFPA, all these regulations that come to touch. And the crown of that one is if you do that in an efficient way. And an efficient way, dust collector, what does this mean? There are different aspects that are important to know and that will be touched in this presentation. First of all, it's the filtration efficiency. This means we have to separate reliable dusts, fine dusts, very fine dusts, abrasive dusts. We have to work on constant pressure drop. We have to work without interruption of the process. We have to do it energy efficient, so use as low as possible electrical and pneumatical energy. We have to consider safety. We have to apply smart safety concepts for explosion, for fire, for the hazardous dusts. We want to stay environmental sustainable. This means the effects on the environment must be reduced, be it by low emission rates, be it by the composition of the materials, be it by long lifetime. And of course, the key that the operator is finally happy is if the system is perfectly integrated in a system so that he can run his system always on the same conditions all the time. And the next presentations are, or the next part of the presentations are just showing the different aspects of that one. Basically, you look into a flow sheet, this is a filter unit and doesn't look that complicated. I think I repeat what my previous speakers said, but in the end, there are a lot of factors to be considered to choose the correct filter system that would work perfectly and will also bring the efficiency to your process. So this normal flow sheet can look in reality like this one. This can be round filters, this can be big filters, bigger filters, this can be filters with a lot of reinforcement on that ones. This can be small units, round filters, silotop filters. So there's a huge variety. And so to find the right one for your system requires to know the process. And then you can go on selecting the equipment, what you need. Let's start with the casing. The basic differences are round and rectangular designers. I've got here an extract of the type series we have got. You also see there is some information, the key features of it. What you see is pressure is an influence, Space is an influence. The kind of equipment you have to attach is an influence. And I have just mentioned here a few. This is not all. The list is not the list is of course not complete. You have to know the required vacuum to choose the right fan. You have to know the pressures to know what kind of casing you need. The product load means to consider in the design to make a pre-separation. The discharge system must be able to handle the high rates. Abrasive dust is always a topic on the casing, on the filter elements. If you want to have product recovery, you don't want to contaminate the product. This means you have to keep surfaces in certain conditions. You have to have an eye on combustible and explosible dusts. Sticky dust is a big challenge for filters. We have a very good solution for that one. Place of installation is in terms of temperature important. If you install it outdoors, you have to avoid condensation, to avoid humidity. Humidity and dust is not always a good combination. And finally, the process integration. This means the control systems of your system and the filter unit must work together. So the interface has to be the correct one. When we talk about the casing, we have to go the next step to the inside of the filter, and this is the filter elements. Of course, I'm focusing here on the Hoerding filter elements. Hoerding sinter plate filters are a big name on the market. They are known for the long lifetime, 10 years and more. For a set of filter elements is not a big deal for us, happens all the time. Very important, constant operating conditions. The pure surface filtration will provide operating conditions that are stable, the pressure drops. The clean gas values are typically very low on the normal filters, smaller than 0.1 milligram per meter cube on this filter stage, resistant to chemicals, and the rigid body design makes it very durable. And as it doesn't contain any filaments and fibers, it will not contaminate the product in the filter by any kind of loosening materials. I've prepared, or not me prepared, but there's a small film in here who shows what is surface filtration. This means dust particles are collected only on the surface of the filter and get then knocked off again. How is this done? We have got a rigid body, that is the carrier, and an embedded surface coating, microporous, on which the actual filtration takes place. Compared to flexible conventional filter media, we have no movement in the filter element, not during suction and not during cleaning. This means, first of all, there's no flexing on the element, on the filter media that will tear it up at some point. And on the other hand, it doesn't open up the pores so that particles can get into the filter media. So when we are doing the cleaning, there is no movement, but the dust is knocked off by an impulse, compressed air, and will fall down. You can see this in a real video. Links left side, you find the conventional filter media. On the right hand, the Hoerding sinter plate filter. You see the dust is just sliding down, not whirled up, and very, very well cleaned off the filter so that you get back on the same filtration pressure drop after the cleaning system, after the cleaning took part. So this means you have got stable conditions. The filter element, one thing very important in terms of, I mentioned it for environment, is be able to recycle it. We have got here even better, we can refurbish it. This means we have got you can return filter elements to us. We will remove the surface coating, apply new one, and you get back an element almost like a new one, but on the old body. And very important also, since last year, end of last year, Hoerding works only with PFAS-free filter elements. So the regulations in terms of PFAS are already covered with our elements. And this refurbishment process plus the PFAS-free properties give you a reduction of CO2 footprint. This saves for the environment, saves energy, saves costs, and wastes, of course, reduces, of course, the waste needed for production of filter elements. We talked a lot about, or we heard a lot of information about explosible dust. We have here also another aspect. It's the fire protection dust that is combustible. There are always 3 steps of protection. The one is the primary measure. This means either you avoid combustible dust by substitution or by passivation. This means adding an inert material to the dust so that the mixture is non-combustible, or you avoid oxygen if this is possible, to take out the oxygen from the extracted gas. Secondary measures are the avoiding of effective ignition sources from the filter unit, from external, but also from the dust. And the tertiary measures are constructive measures. This means we have got a fire detection, alarming, and firefighting system available. Herding Flame Break works with a detection system based on heat detection cable. And if this is triggering and you choose the firefighting system with it, you can choose between aerosols or argon as a extinguishing agent. Similar is for the explosion protection. I think I repeat here a little bit what Mr. Muschel already told us, and Mr. Nägele also told us. Primary measures, secondary measures, tertiary measures, same here. Avoiding combustible dust, avoiding oxygen, avoiding effective ignition source. And when you talk about the constructive measures, there are different ways to handle this. The classical rupture disc, explosion panel, flameless version of it, where you have got the pressure relief into a quenching cage. You can use filter units that are fully explosion pressure proof or pressure shock resistant proof, and you can use suppression systems. And what I want to show you is one particular design that we have got with the Herding sinter plate filters with its unique properties. It doesn't break even in an explosion or starting to burn an explosion. What happens is we can vent on the clean gas side. So instead of having the emissions of fire and flame to the atmosphere, we are going through the filters, so there's only hot air coming out of the filter. So this is Herding flameless. It's flameless, free of flame and free of smoke. So perfect for indoor installation, even for hazardous dust. We are also having to face what the previous speakers were very much focusing, the hazardous dust and the different methods to have to protect the operator from exposure to toxic dusts. We have here also safe change with the classical BIBO design, what is shown here, back in, back out, but also we have got the CLS systems, continuous liner systems, together with the Herding first rinse. A specialty, we don't have the back in, back out system on the first filter stage, on the working filter stage. The plates are simply too big. We are working with first rinse. It's a washing of the elements before you can take them out. And the whole system was tested by the ILU a couple of years ago, and we could prove exposure levels smaller than 0.25 micrograms per meter cube during all steps of operation. We did during operation, after operation, during service, during cleaning, during when we had an error on the system, and we could prove that this is smaller than 0.25 micrograms per meter cube during operation. So this is like OEB5 level from the tables we saw before. The pre-coating, the system for handling sticky dusts. Sticky dust, when we talk about pharmaceutical industry, sticky dust is, for example, especially created when you have got film coating. When you use acrylic resins to coat your tablets, this is extremely sticky, would clog filters very, very quick. Our solution is pre-coating. We apply by a small side machine, we apply protective layer of a filtration additive, typically a mineral dust, so that on the surface of the filter, a layer of protective material is applied, and the sticky dust is hitting that protective layer, not the filter elements. And the cleaning system will be easily able to knock off this protective layer together with the sticky dust, and the system applies a new layer after that. So this allows to work on constant operation even with very sticky dusts, and apply and create a lot of lifetime longer than usual. Digitalization. We heard about Industry 4.0 already. Next step is, of course, AI. We are in there. What we can already offer here is we have our own control system, the Herding HC 4.0, that has got an OPC UA interface, so that we are ready to connect to other machines on a defined interface. We are already doing this with a number of customers to get additional information that helps us to optimize the operation, to adjust parameters, to get better operational behavior. Just by knowing what happens on the incoming side, we can react on that one. This goes hand in hand by visualization and monitoring. On top, you see one of the filter units we have got in our own production. We can visualize this on a web-based possibility. Flow simulation, also an in-house product from us now that we can, of course, we do it for our own filter units to optimize the design, but also when it's about to engineer for customers, ductworks, capturing systems, and so on, we can use the help of flow simulation. Yeah, this was in a quick hurry look on many things where you have to know what to do and what can help you to increase the efficiency. I want to finish the presentation by a few examples. This is, for example, one in the pharmaceutical industry. This was a big benefit for a customer. He had 16 filter units in his production, and he had 16 points where he had to change the dustbin regularly. And this has been reduced to 1 point. This is a central vacuum system that sucks out the dust of all the filter units in this building, so that there's only one central point where the dust is collected. You will find underneath the filter as a dust discharge CLS system that works even with a welding system to close the bags. So a huge benefit to reduce the risk of exposure by handling the discharge. You're here on a very safe side, including all the measures for safe change of the filters for the first rinse system, including dust explosion suppression system in terms of explosion detection. Then there are 4 pictures on one page. On the left top, completely different from pharmaceutical. This is concrete block, very abrasive dust, very heavy dust, would kill the filters very quickly if you don't take wear protection on the housing. Our filters anyway stand the abrasive dust without a problem because there's no flexible movement. It's a rigid body, doesn't move. The dust cannot attack the filter elements. Long lifetime here again. And you see here also the ductwork and so on that picks up the dust from the grinding, polishing places in the system. Next system is crop protection units, pressure shock resistant 10 bars, very dangerous dust, crop protection, insecticides, pesticides, herbicides, with a dust discharge system by the customer that brings back the material into the building. Classical receiver on top of a silo for starch, 6 tons per hour product, 6,200 meter cubes per hour airflow with constructive explosion protection. There's a rotary airlock as an isolation to the silo, but this takes all the material coming from the pneumatic conveying system. And finally, a bigger filter for almost 35,000 meter cubes per hour, 20 tons per hour of mineral dust, calcium carbonate, downstream of a mill and a classifier, and is a typical process integrated filter. This means this is just taking out the air from the mill and bringing it to the packing stations and to the classifiers. So yeah, typical process filter. Yeah, what is upcoming? I invite you to visit our stands on the Powtech. We have got an own stand in Hall 9, 213, and we are also proud to be member of the stand of the VDMA. So it would be great to see there because we have got something to present. You will see it isn't completely black. It is a new filter unit series we are presenting, the Hörding Flex Pro. And if you want to see it, visit us. A very, very interesting new product that combines all the efficiency points that I mentioned. Yeah, and this brings me to the end of the presentations. I would be happy if there are some questions. I would be more happy if we meet by person on the Powtech. And yeah, I say thank you for your attention.
Thank you very much, Mr. Götz. Very interesting presentation also from your side. So as he said, please feel free to ask now your questions over the F&A button at the bottom of your screen. Near the chat function, there is a button which says F&A or Q&A, and there you can type in your question and I will forward it to Mr. Götz. So I will give you a few moments that you can type in. Okay, let's start with the first question. What is the key difference of the Hörding filter elements to conventional filter media?
I hope or try to show it on the presentation. The key difference is we are working on a rigid body design where the body is a strong carrier and the coating where the actual filtration text part is embedded into this body. So there's no movement, no flexibility in the media. This means on the one hand, we are not affected, or the elements are not affected by any movement that would tear up and would lead to a dust leakage. And the second thing is it provides the pure surface filtration so that if we knock off the dust by the cleaning system, we will get back to the same pressure drop as before, this time and time again. So the very long lifetime at constant operating conditions.
Okay, perfect. Thank you. Also another question, the new Pro element, what has driven the development?
Well spotted. This was the one in the middle of the overview of the filter elements. The Pro element is a complete unibody. It's made out of one material. It's only made from PE. There is no parts glued or mounted on it. It's one part unibody with a radial gasket. It's also big news. And this unibody design makes it perfect, for example, for product recovery, especially when food grade is needed because there's only one material to check. But this is also being visible and presented on the Powtech then.
Okay, perfect. Thank you very much. So if you have any questions also left and maybe you know the questions after the talk, then feel free to get in contact with Mr. Götz directly or with us at Powtech Technofarm team. So then we can also forward the question there. And I see we get another question for now. Especially with regard to your PFAS-free filter elements and the new Pro one. Thank you for the interesting presentation. And for now, how do you rate Herding dust extraction system in terms of GMP compliance and product recovery? In particular, how do you prevent potential contamination from material abrasion or product changes due to deposits in dust collector itself? In other words, beyond the filter element.
Okay, very long question. But thank you very much. What we do is we have a very strong engineering department, and we have a very good, let me say, we can very good show different type series of ours with the different points where dust could deposit inside the filter. You always have to live, there are corners and edges. We have different filter units with different properties, and together with the customer, we are going through the critical points and look what does his process accept or what does his production accept. In the surfaces, this can be different solutions. We have units that they are polished down to smaller than 0.3 microns on surface coarseness. We are using different kind of surface lining, depending on the different processes, if it's ceramic, in some cases, even ETFE. So there is, it's always a combination, and the abrasion of the system, you also want to keep down by, keeping the velocities low in the filter. So avoid strong impact on surfaces, and on the filters itself, abrasion is a topic. And if you want to talk about product change and decontamination, you have to know how far you want to go and have to go. Then it's either having a simple filter set change, so a dedicated filter set for a dedicated product, or we talk about washing the filters.
Perfect. So thank you very much for asking this question and for answering all the questions. So we're now at the end of our talk, also from our time. So thank you again, Mr. Götz, for your interesting presentation.
I say thank you.
Thank you. So then also now again a big thank you to all of our speakers today, and also to you for joining our virtual talk today. As you will have noticed at the beginning, our upcoming dates are especially Pautec Technofarm in September, and also Fachpark and Partec also in September. So please join us, and also I sent the e-code for a free voucher code for a visitor in the chat function. So please use it to generate your ticket and to see everyone in September in Nuremberg. So if you want to stay up to date, please also feel free to join our social media channels such as LinkedIn or Instagram or Facebook. So then we can meet up there. So stay tuned for our next virtual talks. So we're making a month, 2 months no virtual talks. So we start then in October again, but we will see first us at September at Pautec Technofarm. So then have a nice day. If you have any questions, please feel free to write us or to visit our website, and then we will meet us at Pautec Technofarm in September. Thank you and bye-bye.